In this video, we will discuss the use of set terminology. A set is a collection of items, numbers, a collection of items. Numbers that belong to a set are called members or elements of the set. The description of a set clearly distinguishes between the elements that belong to the set and those that do not belong. This description can be given in words or by using set notation. One notation is to make a list of the elements of a set. The elements are enclosed in braces and separated by commas. So for example, we could say the set of whole numbers between 1 and 8 is equal to the set of 2, 3, 4, 5, 6, and 7. Here are some common symbols for sets. The following capital letters are used to denote the indicated sets of numbers. So N represents the natural or counting numbers, W represents the whole numbers, and Z represents the integers. The rational numbers are represented by the letter Q, the irrational numbers by I, the real numbers by R, and finally, a couple that we will not be using in this course, the imaginary numbers are represented by M and the complex numbers by C. Symbols that often replace phrases that are often used in describing sets are this little vertical line, which means such that, and this kind of backwards round E, which means is a member of or is an element of. Another method of describing a set is set builder notation. The elements of the set are written in the form of an inequality using a variable to represent all elements of the set. So for example, if we have the set of whole numbers between 1 and 8, that will be the set of all x such that x is a member of the whole numbers and 1 is less than x, which is less than 8. There are multiple ways to read that. The one I just gave you is fine. We could also say the set of all values of x such that x is a whole number and x is between 1 and 8. Either way is fine. An empty set is denoted as a circle with a slash through it, and that is a set that has no elements. So for example, the set of numbers such that x is equal to 7 and x is not equal to 7 is the empty set. There is no number that is both equal to 7 and not equal to 7. So in this example, we will answer some true or false statements about sets. First, we ask, 5 is an element of the set of whole numbers. And that's true because the whole numbers are all numbers from 0 to positive infinity that have no decimal and no fraction attached to them. B, 3/4 is an element of the set of Z. Z represents the integers. So this is false because the integers are all of those numbers that the integers are the numbers that they're the whole numbers and the negative whole numbers. So this one was true and this one is false. This third one, -8 is a member of the set of real numbers with the probability x, the property that x is, this isn't a property, this is just a set. This should just be the property that x is less than or equal to -5. Well, -8 is less than or equal to -5. It's less than -5. So it is in, and it's in the set of real numbers. So this is correct. This is true. Next, 3.7 is an element of the set of rational numbers with the property, and again, not a property here, that's a set. Property that x is greater than 3.7, though, this is definitely false because 3.7 is not greater than 3.7. And finally, we've got the set of prime numbers that are evenly divisible by by 2, is an empty set. That's not true because 2 is divisible by itself, and that gives us 1. And 2 is a prime number. It's the only even prime number. All right. So to identify the elements of a set using a list or set builder notation, first, if we build a list, first we list the elements of the set, separating the elements with commas. And then second, we enclose the list in braces. For set builder notation, first, represent the elements of the set with a variable. Write the symbolic statements that identify the elements of the set. Use the symbol, that little vertical bar, to represent the phrase such that, and enclose the results of steps 1 through 3 in braces. So here are some more examples. We'll first write the set of integers between -2 and 5 as a list. The word between does not include the stated boundaries, so the least element in the set is -1 and the greatest is 4. This is the set -1, 0, 1, 2, 3, and 4. Write the set of numbers that are greater than 5 in set builder notation. So we let X represent the elements of the set, and then we note that the set of the rational numbers is represented by the letter Q. So this is the set of all values of X such that X is a member of the rational numbers and X is greater than 5. I believe that's the last page. Yes.